All right, so last video for this section, we were doing the word problem. We want to find the total area. We know the total area, and we want to find the side length x for each squared plot. So we're trying to plan a flower garden. We want 3 square plots surrounded by a 1-foot border. So if you're looking at the picture, this gray is that 1-foot border. Okay, the total area of the whole garden with the border is 100 feet. It's going to move us on, but oh, there we go. So we know that our total area equals 100 feet. And if we're doing area, area equals length times width. So now I need to figure out what is my length, what is my width, right? So my width is going to be this x, right, plus the 1 foot here and the 1 foot here. So I've got an x for my width. I've got an x plus 2. And again, the 2 is for the 1 foot plus 1 foot. All right, so with that in mind, with my length, I also have 1 foot on both sides, right? So I'm going to add 2 to it. But the difference is on my length, I go all the way across, right? So that's 1, 2, 3 x's. And so this is going to be a 3x plus 2. So then we're going to plug in to our equation. So we're going to get length, 3x plus 2, times width, x plus 2, equals 100. From here, we're going to FOIL. I'm going to take 3 times x, which is 3x squared, 3 times 2, which is 6x, 2 times x, which is 2x, and then 2 times 2, which is 4. Still equal to 100. Now from here, 3x squared plus 8x plus 4 equals 100. Now, it's wanting us to solve, and we have that 8x value. And it's not going to be super easy to factor because of the 3 in front. Yet. It's not going to be super easy to factor yet because of the 3 in front. So what I'm going to do is I'm going to subtract my 4 from both sides. So I get 3x squared plus 8x. I'm going to put my plus blank equals 96 plus blank. Now, the issue is when we're doing completing the square, we only want 1s in front. So I've got to divide everything by 3. Not my blanks yet, right? So now after I've divided everything by 3, I have got x squared plus 8/3 x plus my blank equals 96 divided by 3 is a whole number, equals 32 plus blank. All right. Now you may go, Mrs. Cartwright, there's fractions and we hate fractions. Take a breath. I gotta find my c, so I'm gonna take that b, which is 8/3. I'm gonna divide it by 2, and then we're gonna square it. Well, I'm going to do this off to the side here. There we go. 8/3 divided by 2 is the same as 8/3 times 2. All right, divided by 2. Times 1/2. My bad. I've got to flip my bottom fraction. And so multiplying across, we have 8/6, which becomes a 4/3. So that's what I got over here. So now I have 4/3 quantity squared. And just like we learned in chapter 7, we distribute the square and we end up with 16/9. And so that's what I add to all my blanks here. 16/9 and 16/9. All right, this one here, because this is a 1, right, we're going to have x plus this 4/3 that we found here. So x plus 4/3 quantity squared. equals, and then I'm going to take that 32 plus 16/9, and I'm going to end up with 300. I did it in a calculator before you're like, whoa, Mrs. Cartwright is super awesome with her fractions. No, I did it in the calculator but ahead of time. But 32 plus 16/9 will give us 304/9. And then it wants us to solve. So I've got to get this squared by away. So I'm going to square root everything. And so that gives me, I'm going to have to move, we're going to move off to this side. There's more room. What that gives me after I square root is I'm going to have x plus 4/3 equals, technically plus or minus the square root of 304/9. Now that, so I'm going to have x plus 4/3 is, oops, no, go back, don't do that to me, is approximately plus or minus 5.812. And so then when I subtract, right, I'm going to subtract 4/3 from both sides. And so, and I know I still have this, you can write it as two separate equations, but I have an x equal, or is approximately, right? If I do 5.812 minus 4/3, I end up with 4.48. If I do a -5 minus 4/3, I get approximately 7.15. A negative 7.15. Well, negative doesn't make sense in this, so that one goes away. And so I am approximately, they need to be approximately 4.48 feet each. So each side needs to be approximately 4.48 feet for it to be a perfect square. And that's how we use it. And see, that took us 7 minutes. That's why I didn't want to add it to the other video. Again, don't let the fractions scare you. But the reason we did it is because it makes it easier. If we would have subtracted the 100 over, we may not have been able to factor. I don't know. I'm just doing what the book tells me, which is to use the completing the square. And so this is one of those ways where we can use completing the square to solve a word problem. So I hope that helps, and I will see you in class.